Hello and welcome to section 2.3 product and quotient rules, and in this unit, this section, we are going to be going through some more basic rules that we need to know to find derivatives, which will basically help us find the slope of the tangent line or rates of change or any of that stuff that we've kind of been talking about. So first rule that we have is the product rule, and this is when we have two functions multiplied together. And so you can copy this down. You need to know it. You need to know what the rule is. Basically, you take the first function, multiply by the derivative of the second, add on the first function or the second function and the derivative of the first. And so that's basically what the product rule is, and we're going to use this so much that you will know it by the end of this time. And then there's an extended product rule that if you have more than one function, you can multiply the derivative of the first times the second 2, then the derivative of the second times the first and the third function, the derivative of the third times the first and the second. Occasionally, and probably in class, I will write this one like this: f prime of x, the derivative of the first times the second, plus the first times the derivative of the second. And the reason I do that, you'll see when we get to quotient rule, that this follows the quotient rule pattern a little bit more, and so it's less to remember. So that's just one of the reasons why I write it that way. But it's the same thing. Because you're adding in between, it doesn't matter what order you do these in. So here's an example of it. If I have a function, something like this, say my function is x squared plus 3 times x squared minus 4x. Now, you could multiply these out if you wanted, use FOIL, use whatever, the distributive property, whatever you want, and multiply these out and go ahead and do that. But I am not going to. I'm going to call this guy f of x and this one g of x, even though this is called g of x. But if I take the derivative of this function, of the, well, let's call this h of x so we're not confused. If I take the derivative of the g of x function, the original function, then I take the derivative of f of x times h of x and add on f of x times h prime of x. So that's what I'm doing following my product rule. And so now if I just go ahead and do that, I can simplify this. So the derivative of this, the derivative of g of x, g prime of x, is the derivative of this function. Well, it becomes 2x. And leaving h of x alone, I get x squared minus 4x. And then leaving f of x alone, x squared plus 3. And the derivative of h of x looks like it's going to be 2x minus 4 when I take the derivative of each part. And so the only thing left for me to do to get my final answer for g prime of x is to simplify this, and that would be distribute the 2x and multiply these binomials together. And so that will give me something like 2x cubed minus 8x squared. That would be my first terms. And then down here, when I take 2x squared times both of these terms, I get 2x cubed minus 4x squared, and then 6x minus 12. And so final answer is to combine all of these guys together. And let's see, it looks like I've got 4x cubed. Those guys cancel that, or combine together. Negative 12x squared plus 6x minus 12. And that is what I'm looking for the derivative of these two guys. Now you're probably thinking, well, that's kind of complicated. Why don't I just multiply these out? You can multiply them out, and then when you take the derivative, that's what you'd end up with. So either way, it's up to you. But I would consider learning the product rule because we're going to use it a lot in this section and in sections from here on out. So then we have the quotient rule when we're taking two functions and dividing them. And so you can kind of see the way this is written, that I'm taking the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared, as long as the bottom is not 0. So we're going to go ahead and do a quick little practice of this. And the function that I'm going to choose is h of x will equal x plus 5 over x minus 5. And so if I'm going to take the derivative of this, I take the derivative of the top, which is just 1, times the bottom, minus, leave the top alone, and take the derivative of the bottom, which is just 1, all over the bottom squared. And so simplify the top as best we can. This was h prime of x. And so moving down here, h prime of x will equal, let's say, x minus 5. And if I distribute the negative, I get negative x minus 5 all over x minus 5 squared. No need to multiply out the bottom part. We can just leave it like that. It'll be more useful to leave it in a factored form. So we'll leave it like this. You'll see the x's cancel out. So I'm left with h prime of x is negative 10 over x minus 5 squared. And so that's what we're looking for when we take the derivative of this quotient. So other things that we have to consider is taking the derivative of trig functions. And basically, we can take the derivative of trig functions, but all the trig functions will be broken down into sines and cosines. And so you'll notice, like, you're going to need to know these. You just need to kind of memorize them. But we're going to show you how tangent works out to be secant squared. And so basically, if tangent is written as sine over cosine, it becomes a quotient rule. And so if I take the derivative of the top, sine becomes cosine times the bottom, which is cosine, and then leave the top alone, which is subtract the top, times the derivative of the bottom, which is negative sine, all over the bottom squared. So just following the quotient rule, I went through and did sine and cosine. And then you'll notice that I get cosine squared plus sine squared, which is one of our Pythagorean identities, which means that that becomes 1, and we're left with 1 over cosine squared, which is the same as secant squared. Now, I promise you that all of these guys work out the same type of way, similar, when you change them to sines and cosines and go ahead and do the derivatives of them. This secant tangent and the cosecant cotangent, we'll talk a little bit more in class, and I get those. There's a little bit of a trick to them, but nothing major. But you should know these, and you should know how to get them, just in case you forget these. So we'll talk more in class, so please come with your questions. And then finally, we have the derivative. The first derivative is what we call the velocity function. The second derivative is acceleration. Sorry, it wrapped around the corner there. Third derivative is the jerk. Fourth derivative, and so on. There's more derivatives after that. You could take the nth derivative, but these are all the different notation for the different derivatives, and so you need to make sure you know these, make sure you get them down, because we will be using them. We'll be asking for the second and third derivative from time to time. Occasionally it'll be higher than that, but you need to make sure you get these down, and this is just the different notation for each one of them. Most common ones are these y value ones or the f of x ones, but occasionally these guys will pop up to the dy over dx ones. And so those are the most common. The first 3 columns are the most common, but please copy these down. Please pause this and make sure you get these so that we can talk about them. And be very careful copying them down because of the way they're written. So this concludes our derivative talk, our higher order derivative, and our chain rule and product rule, our quotient rule and product rule section. So if you have any questions, please come to class prepared to ask them.